My name is Adriaan Rol. I'm one of the founders of Orange Quantum Systems. And today I'd like to talk to you about our vision for the quantum industry. So all of us are here today because we believe that quantum computing is becoming a reality. And our vision is that quantum computing will become a mature industry, and that industry will very closely resemble the semicon industry that is already there. But what is required to realize this? Now, as we all know, the digital world is growing, and we're running into the limits of classical computing. Quantum computing is one of the best solutions out there to take us to the next step. And we're also seeing that there's great achievements on the technical level that are really pushing us to the next level. We've seen in 2019 the first demonstration of a quantum computing doing something that could not be done classically. And then, since we're in Paris here, I thought I'd highlight some of the big European achievements. We built the very first European quantum computing, but that's also the first quantum computer with multiple quantum systems behind it, both a spin and a superquantum qubit system. Quantware released the world's first commercial quantum chip, and IQM has opened their first quantum chip foundry. So this is all amazing. But we also know that to realize a commercial quantum advantage, something actually useful, we need more and we need better qubits. This is an overview I've compiled of the state of the art in the world. And what we're seeing is that the full fault tolerance is still quite a bit away. But there's the NISQ era with lots of potential applications that will need the techniques such as the ones presented in the last pitch. But what is required for us to move up and to the right? Now, on the one hand, we need better fabrication processes. And the good news is that it was recently demonstrated by several leading entities such as Intel and IMEC that the fabrication of solid-state qubits, such as superconducting qubits, spin qubits, is in fact compatible with foundry-based processes. But the other thing you need is the knowledge to know how to improve these qubits. And testing of quantum chips is significantly more difficult than the testing of classical chips. And the good news for us is that even though these tools are now missing, it is expensive, slow, and difficult. You need a high-tech cryogenic lab. It's very slow and manual to do it, and people need to have a PhD to know what they're doing. This is great news, because this presents us with a unique market opportunity. And in fact, it's not only that we have the promise of the quantum chip fab market when the big players move in, but already today, we have sustainable revenue in the R&D market. And this also allows us to build technology and a reputation to serve the early adopters. We're now seeing quantum startups and high-tech companies with a quantum vision already moving in that market. And this is what we're going for. Because what Orange Quantum Systems does is we build high-throughput test systems. And they can provide orders of magnitude cost reduction in the test cost. There's one thing I want to highlight here, which even surprised us. So we interviewed all these leading players, and we learned that today it costs over 10,000 euros to test just a single qubit. Now, we're never going to build our million qubit quantum computer like that. So we want to bring that down to the Eurocent level. So our current products tackle the test bottleneck in the R&D market. So we have products ranging from software libraries, the Orange Rack, which is an integrated control system to control these systems, to selling a full Orange system, which is effectively lab. But to bring this to the industry, we need to take this a step further. So what we are doing now is we're integrating this into an integrated system that is optimized for speed and usability, thereby significantly reducing the test cost. The business model we're using behind that is also inspired by that of tool providers in the semicon industry. So what we do is we provide systems on-premise, and then we provide paid upgrades and service models. But the most important reason why this business model works is because what we're addressing is a strategic capability. The thing that limits the ability of people to improve their quantum chips is the test capacity. And we provide a tool to increase their test capacity. So that means that we will also be viable once we've done this once, because every new generation will need to be measured. So our team is ready to scale. Our founding team led the development of Europe's first quantum computer. And with the help of happy customers, we've been able to scale that team to 17 FTE. We've also been able to set up a truly great advisory board. We have Dr. Jan van Schoot, who is Director of Systems Engineering at ASML. We have Professor David DiVincenzo, who literally defined the criteria that we use to judge qubits by today. And we have Dr. René Penning de Vries, who's the former CTO of chip manufacturer NXP and an icon of the Dutch tech industry. So to summarize, the digital world is growing, and the chip industry will need fast testing systems. Now, we deliver these test systems, and the chip industry will soon start the mass production of quantum chips. So now is the time to capture this emerging market. Thank you very much. Do we have a microphone? That's a great question. So what we're doing now is effectively on par what you can see in most of the quantum startups. So that's reducing it by a bit more than one order of magnitude, so you're down to the hundreds of euro level. The big gains are to be had with relatively straightforward innovations. So we're thinking 2 to 3 years. Yes, so you provide a system on-premise that is fully automated and contains several innovations to speed up the process, reduce the capex of the system, increase the size of the device you can handle. I can discuss that offline with you if you like.
I could see you use the superconducting qubits. We could see that the dilution fridge and stuff like that. Are you also developing technology for photonics, trap ions, neutral atoms, NV centers, or is it just superconducting qubits?
So we are in principle system agnostic, but that means something within confines. So we're compatible with solid state qubits. Right now we focus on superconducting because that's the most mature technology. We believe that we need to demonstrate that this can be done, just to validate that it can be done. But we also have projects with customers in the spin qubit space and in the NV center space, specifically because these are also solid state qubits. They're similar and they require only changing a subsystem of the total system. It also fits in with our market entry strategy that we first focus on the R&D market to ensure that we both develop the technology, build a reputation, but also stay up to date with whichever platform will emerge. And to be completely fair, photonics are sufficiently different that I will not claim that we're compatible with those. That's just too different.